Good morning and welcome everybody to this edition of the A4Q Testing Summit 2025. It's going to be a fantastic day and I am very proud to be able to host Lilia Gargouri. Hi, Lilia.
Hello.
Hello. Lilia, you're going to talk about the power of model-based automation, which I know is going to be absolutely full of really interesting information. I'm not going to do too much of an introduction, other than to say I know you're with MGM Technology Partners, an experienced leader in software quality assurance. I'm going to just remind the audience to pop any questions into the comments box. And if we don't get to them during the session, then we'll try to get answers to them anyway. And also just remind people that we can vote for the best presentation, best speaker, if we go to Lilia's profile at the A4Q Testing Summit website. Lilia, I'm going to get off the stage and hand over to you because I know this is really going to be great. Over to you.
Thank you so much, Debbie. Hello, everyone. Thank you for joining the A4Q Testing Summit 2025 and welcome to the presentation, The Power of Model-Based Test Automation. My name is Lilia. I am Head of Quality Assurance at MGM Technology Partners. I worked at MGM over 15 years as software developer after studying computer science at the Technical University in Braunschweig, North Germany. I worked as back-end software developer in diverse projects, among others in public sector. MGM is a software house. We are specialized in the software development of enterprise software, which means complex business long-life applications, and we will have a look today deeper into this complexity. One of our MGM famous software products is Mein Elster. This is a German portal where citizens can submit, among others, their income tax returns. Over the last 10 years, I worked intensively in the field of quality assurance, especially in test automation. Currently, I am leading the technical quality assurance of the MGM low-code platform A12. Additionally, I am the project manager of the MGM quality team. This is a cross-project expert team in quality assurance. We are accompanying customer projects in efficiently establishing and implementing their QA needs. Now, let's move to the agenda. At the beginning of my presentation, I will explain the model-based approach. Then we will talk about the challenges in the quality assurance of enterprise software. Afterwards, I will present the model-based quality assurance, including a short demo. Last but not least, at the end of this presentation, we will have a small Q&A session in case you have any questions. So let me start with the first point. What is the model-based approach? In traditional software development, the business expert reads the requirements and writes a business specification. The developer reads the business specification, most likely writes a technical specification, implements the code is deployed, and the application is running. When using a model-based approach, the business expert reads the requirements and models the business logic using a modeling tool. So we see here the UI of a modeling tool called the Simple Model Editor of the MGM low-code platform A12. So the business expert creates a data model using the editor, which is physically, this data model is physically a JSON file, and creating the data model by modeling the necessary fields and validation calculation rules that are required to reflect and build up the business logic of the form. Suppose, let's have a small example. Suppose we need a tax form having two fields, first name. So the business expert creates a field using this editor, creates a field having the data type string because it's a text field. And then we need a second field, date of birth. And this field has the data type date because it's a date. And most likely for our form, we need a validation rule telling if the field first name is filled and the field date of birth is not filled, then the user, the end user, should get a validation error on the UI of the form telling, please enter your date of birth. So you see, it's non-technical, no technical knowledge is required. The business expert, most likely the customer even, can reflect and build up the business logic using this editor and using a rule language which is human interpretable, human understandable. And the nice thing is he can build up complex business logic by using this language. And this language is also machine interpretable. This is not all. After building up the business logic and creating the data model, the business expert can use the tool to design the UI of the form, creating a model called a UI model. So now I can specify what is the label of my field. Should I group my field in sections? What is the label of my section? Is my section collapsible? Yes or no? I have a string field. Should I display it as a text field or text area? Is my field a required field? I have a yes/no field, so should I display it as a checkbox or radio button? Is my field read-only? Do I need a header action bar? Do I need a footer action bar? What are the actions? And so on and so forth. So the business expert can design the UI of the form, correct the design, because he has the opportunity to have a preview. By using this tool, he can see what the form, how the form looks like, and correct the design of the form till it's done. So a form is later created based on the data model plus the UI model. So let me summarize the model-based approach. In the model-based approach, the business expert reads the requirements and creates models. So data model, UI model. These models, as I mentioned, are human understandable and machine interpretable. The models are then deployed in the A12 platform. So we generate code from these models. That's why it's called low code, no implementation. For sure, in case there are customer-specific requirements that we cannot model by using this rule language, the developer still has the opportunity to implement custom code to basically cover specific custom requirements. So the code is added together, so it's integrated together, the code is deployed, and the application is running. So in the model-based approach, you see here a strict separation between the domain logic and the technology, making it basically possible to apply a very early testing of completeness and correctness of the business logic at a very early stage, which is a shift-left approach. Just as a side note, MGM is currently in the process of clarifying with its customers and partners whether A12 can be open sourced. In my opinion, that will be amazing. Why? Because A12 is a very useful platform for efficiently building complex business logic, especially for insurance, financial, and public sectors. Now let's move to the second point, the challenges and the quality assurance of enterprise software. I mentioned the complexity. Now the question is, how complex is the business logic of enterprise software? Let's take a closer look at the business logic of one single tax form variation to gain impressions about its complexity. So this is an overwhelming complexity of business logic. And I repeat, this is one single form variation. So now imagine it, you have an application having 200 to 300 form variations with that level of complexity. How can you ensure a good quality for every form? This is an example of a text form, and you see the small black points. These are fields in the form. So we have over 2,400 fields. The green lines are validation rules, the blue lines are calculation rules, and the red lines are cross-context validation rules. This is overwhelming complexity. So let's talk about the challenges of the quality assurance of enterprise software, and let's start by valid test data. We need valid test data. The generation of valid test data or the creation is complex and time consuming. Why? Because you have over 2,200 validation calculation rules. This is an arithmetical system that you have to solve, and this is time consuming and complex. The forms are changing frequently, so you have to do this in regression, and this is not realistic. Additionally, you have limited resources and short testing phases, so you have to avoid time-consuming tasks. Additionally, now let's talk about the form. All the functionality provided by each form are critical. Risk-based testing is not an option. You cannot say, I focus only on the changed or the new features and I ignore the rest. Then let's talk about manual testing. Manual testing requires high effort. Why? Because you need to submit these forms when testing. So you need to fill in over 2,400 fields. This is time consuming. Because the forms are changing frequently, you have to do this in regression. This is not realistic. Okay, let's automate them. What's about the automation? Implementing extensive UI and extensive forms. This is a lot of effort. This is time consuming. And then you will very quickly, because the forms are changing frequently, you will very quickly fall into the maintenance trap of test automation. So a lot of challenges. And then you have the pressure, limited resources, short testing phases. So let me summarize. The quality assurance of enterprise software is critical. It's time consuming, highly complex, and costly. How can you do this? So model-based software development requires a model-based quality assurance. Let me start from the very beginning, and the beginning was modeling the business logic in a data model. So now my question is, can we make sure that the business logic we modeled is correct and complete at a very, very early stage? Is this possible? So to answer this question, we invented a tool which is called Test Data Suite that is integrated in the same modeling tool. So the business expert, which can be the customer, after modeling a data model, so after modeling the business logic, he or she opens the tool and load the data model in the Test Data Suite tool. So when loading the data model in the UI, he or she, the business expert, will see basically the structure, the business structure, the business expert modeled, and the data model will be here reflected, the same business structure and the same fields he modeled. And then, so the business expert will not see the rules. So the validation calculation rules, I will explain this. So now we have the possibility to add some data and then click the execute button in order to make sure that specific or targeted validation or calculation rules are behaving as expected. Now the business expert has the possibility to create test cases and structure them so that the business expert can conduct positive and negative testing to make sure that the rules and the business logic, the rules are behaving as expected and the business logic is correct and complete. The nice thing is this tool supports versioning because the own software is also versioned, so it's very useful. Additionally, after creating the test cases, these tests can run in regression in Jenkins. Why we do this kind of testing very early? Basically in order to detect inconsistencies and contradictions in the rules, in the business logic very early, also to detect gaps, so basically missing rules. Sometimes a combination of many rules together make it impossible, for example, to fill in a field so that you can detect this very early. So the idea is by using this kind of tests, we would like to ensure the high quality of the data model, which is the beginning of the story. Yeah, this is the first thing. Now we still need valid test data. How can we solve this? It's too complex and it's unrealistic to do this manually. Let me give you an example. The income tax form has over 2,400 fields and 2,200 validation calculation rules. So there are a high number of possibilities for the field assignments. Field assignment mean assigning a valid test data to a field. Most of the field assignments are dead ends. What does it mean? You start assigning valid test data to fields, but at a certain point, you cannot continue assigning test data to fields because whatever you do, one or the other validation or calculation rule is violated, is unsatisfied. So we need good algorithm for the field assignments. We have to avoid dead ends, and we aim to have high test coverage. It means high field assignments. So now the core question is, can we use or make use of the data model where we design the business logic and generate valid test data automatically? This is the core question. And this was also the motivation. We basically invented a tool which is called the test data generator, for short TDG. The idea of this tool is pretty simple. We have the data model as input, and then we convert the data model with all validation calculation rules to an arithmetical equation system. And we hand over this equation system to an open source library called the SMT solver. The SMT solver is an open source library implementing many algorithms of the satisfiability modulo theories. So now the solver will try to solve this equation system, satisfying all validation and calculation rules. Because solving extensive equation systems can be very time consuming, and to make the solver working very efficiently, you still need to perform some few settings. And then once the SMT solver solves the equation and find hopefully high test coverage test data set, valid test data set, he will return it back to us, to the TDG. We convert it back in the A12 format, and the TDG basically will returns valid test data sets as JSON files. Additionally, it will return an Excel file containing all the fields of the form, and each column is representing a valid, hopefully high test coverage test data set. Now we can conduct manual testing or automation. These test data are synthetic test data, and they are very close to the natural normal test data or productive data. And now maybe you have a question about anonymization, why we didn't conduct anonymization instead of test data generation. Basically, the anonymization of critical sensitive production data like the German income tax is not an option. This you cannot do because the data are very critical and sensitive. Additionally, we have by law always new forms coming and to be tested that we have to cover. And for new forms, without any available productive data, you have no chance. So anonymization is not a solution. Now, another thing, the solver, when solving the equation system, the solver is able to detect contradictions as well, because if there are any contradictions, he will be, the solver not able to solve the equation, and he will throw an exception saying rule whatever plus rule this and that is not possible to solve it because of this or that. Maybe another additional point, if the business change, so the business requirement change, the form change, so the modeler or the business expert will change the business logic in the data model. We regenerate test data, and we can conduct immediately manual or automated tests. And the test data generation or the generation of test data can be done in a regression in Jenkins. This is not a problem. So now we have a time-saving, sustainable solution for test data generation. Now let's move to test automation. We need to automate more despite the changes in the forms, but without going to the trap of maintenance of test automation. So how can we solve this? So the core question, and it's also the motivation, Is it possible basically because models have a structure and are tangible? So the core question is it possible to extract valuable data from the models, especially the UI model, where we design the UI of the form? So is it possible to extract valuable data from these models and generate the code for automation? That's why we call this invention the automation of automation, because we would like to automatically generate the code for the end-to-end test automation and save implementation and maintenance overhead in the automation. So we started extracting useful information from the models for test automation. For example, like the field type, is it a string, a date time, a multi-select? What is the label of the field? Is the field read-only? Where is the field situated? On which section? Is the section collapsible? What is the label of the section? All this kind of information. Then in a second step, we started generating all selectors of the UI elements of the form. I am using the wording selectors for Cypress. We can use locators for Playwright. Basically at MGM, we use for UI test automation, the test automation tool QFTest of the company QFS, Quality First Software. And here with the tool QFTest, the identifiers of the UI elements are called smart IDs. The syntax of the smart IDs or of these identifications are simple. It's basically hash and then the QF test class colon and then the label. And then you can have the identifier for the UI elements. Now we have surely two questions. So how can we know how to convert or to map a native class or a native field type to a QFTest class? Secondly, how can a general test automation tool like QFTest knows the UI in A12? So let me answer this question. So to do this, we invented a small piece of software called the A12 Custom Web Resolver, which is basically mapping the A12 UI elements to QFTest classes to basically do the identification of any UI element in A12. And the nice thing is A12 and all applications, all web applications that we build using A12. How we did this? Pretty simple. At a very early stage in the development of the low-code platform A12, we invented an attribute which we called or we named data role. So we invented a data role attribute in the HTML of each single A12 widget. It means if A12 creates or adds a new widget to the platform, this widget should contain or must contain a data role attribute. The data role attributes are unique, consistent, and never changing. Yeah. So basically, we enhanced and improved the testability of A12 and any A12-based application very early by inventing or introducing these kind of data role attributes. It can be called for data purposes attribute, test data or whatever. So we named basically data role. So now we map the data role attributes to QFTest classes. And then we build up the smart ID to target any UI element. And the syntax of the smart ID is simple. Again, it's hash and then the QFTest class and then colon. If you have a label and then you can add the label and then you target the UI element by label. QFTest is a low-code test automation tool. So we enabled by using this tool the business experts and also the manual tester because it's easy to them to do automation. So you can see now a piece of code from the test automation tool QFTest, and without knowing the application or without knowing test automation, anyone can read this is a mouse click and this is targeting a button with the label save. So you see it's pretty intuitive. Yeah. Again, the smart ID is very simple. So the identification. So if you use QF-test, QF-test is providing features that you can use out of the box, like the mouse click or the input to put a value into a text field. And the identification has a very simple syntax. So it's basically hash. I have a text field, so it's a text field, then colon, and then the label of my text field. And you see here, even the asterisk is part of the identification. Why? Because it's a part of the label. So if we do an identification by label, we are implicitly testing all the labeling, all the headings existing in our application without having the need to explicitly test them. We are covering them implicitly. Why? Because they are part of the used identifications. We recognize very quickly that the customer do not change the labeling of forms frequently, maybe one time, twice, and that's it. So these smart IDs are very accurate. Now, I have a UI on purpose having two text fields, and both of them have the same label. How can we do this accurately? How can I target? Can I target the second text field, not the first one? How should I do this? Additionally to the to the smart IDs, there is a feature in QF-test called scope. You can tell QF-test when doing automation, ignore all the UI, all the HTML, and focus only on this area, which is called scope. The syntax of the scope is also easy. It's add scope, and then basically the smart ID or the identification of the area. In our example is the hash panel company, with the label company is a section. So this is the scope. So within the scope, the text field name, so the second text field name within the scope company is unique, right? So by combining scopes, targeting text fields or UI, and combining scopes with smart IDs with scopes, you can accurately target any element on the UI. So the combination of scope and smart ID facilitate accurate, stable identification of components on the UI. This is not all, and this is the most interesting part in my opinion. So additionally to the scopes and smart IDs that can be used, there is also the possibility to use them generically, which brings more flexibility and open the door for any generic solution and test automation. What I mean is you can have the label as parameter and parameterize the label. You can parameterize the class. You can parameterize all the smart ID, all the scope. You can use regular expression, who name it. This is flexible. This brings flexibility to generic solutions in automation. And this is very powerful. So now let's go back to the generation of test code based on our models, especially the UI model. So when implementing the generation of the code based on the models, we have to consider the following as well, which is nested forms in A12. What does it mean? Suppose you have a text form and you are the applicant. So the text form contains a lot of fields and tables. Our code that we would like to generate should deal with all of this, even with tables. But now you have tables, and if you click the add button, you will be redirected to a subform. So let's suppose you are the applicant and the table is children, and because you have many children, so you click the add button and you will be redirected to a subform called child. And here you have to enter many text field and data, just a fake example. And then you might have many fields and many tables, who knows? And maybe a table like addresses, because your child has many addresses. So you click on the add button and you are again redirected to another subform called address, where you can enter different things. So here we need a recursive algorithm to deal with all these complications and nested forms. Yeah, so that we can later target every field in every table or every subform when doing the automation. So this is part of the generation of the test automation code. Now we are done. We created all identifiers basically for all fields in all forms and subforms. We created not only the smart IDs, but also the necessary scopes, because we know where is every field is located. So we need the sections and the labeling of the sections. So we created the smart IDs as well. Now we use the TDG, the test data generator, to create valid test data. Now we have to integrate the test data with the identifiers, so with the code, with the test code, so that we have fields and then the valid test data of the respective field. Now we are ready to conduct automation, right? Let's first have a short demo and then we continue with the explanation. So let me show you how it works. So here the UI, you see QF test. I am currently generating the code for automation in forehand based only on the models. I am done. I will deploy the models in the in locally, and I will run the server locally because it's just a demo application on my local system. So this is a demo application I modeled. I implement the automation to basically to open the form. And now whatever you see in this area, in the right area, is now, imagine this is now a text form. And I symbolically, I put this figure, this picture in order to tell you whatever is happening now in that part, I didn't implement one single line of code. There's no implementation. This is done by the generated code based on the models. So we generated the code, we generated the test data, we integrated both of them, and then I say, fill me this extensive form with all fields, all table, or widget. So you see here we have a table with a subform. So I click the add, and you are now in the subform, so in a nested form. And QF test is blindly filling for me all the widgets, all the elements of this form with my test data blindly. So you see here a Pika QF test is dealing with the A12 Pika without any code implementation. I tried when modeling this form to use many different widgets so that you see the variety of use. Now, after filling these tables, this is a kind of table. So after filling all the form, regardless how many fields and tables I have in the form, I save the form. And now I simulate also checking all the UI out of the box without any implementation. And if I say no implementation, I say also no maintenance of the implemented code. So now this tool is blindly checking for me my UI, all my widgets, and making sure they contain the test data as expected. So this is the small demo. Now let's go back to the slides. So this was the demo. Now let me explain you how we implemented this innovation, which we call automation of automation, based solely on the A12 models. So the data model, the UI model. We generate the code for automation in forehand. It means it is even not required that the application is running at that time. We don't care. It's just based on the models. The nice thing is now, in case the models change, because the business is changing, the business logic, the business requirements, we regenerate new test code so that tests can run immediately. So we regenerate all the identifiers, everything necessary based on these models. Of course, we need test data. These can be obtained from the test data generator or provided by the user. So you can say, I have my very specific high test coverage test data, and I want to test very specific constellations. You can put your own test data here. It's not a problem. So now we have the test code and the test data, and we need now an interpreter that will conduct the tests with QF tests. I will explain it to you. So basically, the interpreter contains a library that can deal with each kind of widget on the UI of any A12 application. So if I use this automation or this tool, I am using the interpreter providing me a fill or check method, and I say fill my form with the test data Z, and here in the test data I have Z's of test data with test data Z number 2, for example. So basically QF test will iterate my data blindly. So I have a checkbox or I have a picker, so the interpreter will basically pick up the procedure for the picker, and QF test will perform blindly the action and will execute basically this procedure blindly and put basically the test data into the field. This is working with tables, with forms and subforms, with any kind of widget on the UI. Yeah. So how can I use this in my test case? Let's have a small example. So this is my test case. And basically what I do before coming to this form is my business. I design it my way in my test case design. It's my constellation. So basically you navigate to this form, you open the form, and then it's one line of code where you say, fill me this form with the test data Z number 2, just as an example. And when running the code, QF test blindly iterates the identifiers and fill the UI, navigating blindly, because based on these form models, we generated the code. So we know based on these models from top to left, from top to bottom, from left to right, we are blindly filling in all the UI with this. So what you do after is your business. So the ATA, the automation of automation, this innovation or this tool facilitates for you the extensive basically filling and checking of the form, taking over the filling and checking of the form, and accelerating and simplifying basically your automation. So the test design is still yours. What you do before and after filling or checking the form is your business. Why we do this kind of end-to-end testing is really crucial to have at least few of the end-to-end tests. Why? Because these kind of tests are testing the end product where the system and or the systems and every component is not mocked. And this is crucial to detect very critical integration issues. So we see here basically a screenshot of the log file with QFTest. You see it's easy to analyze for a business analyst and manual tester without any technical skills. You see here the mouse click is failing due to this error, which is an integration issue. So we improve the quality and the efficiency in our test process. By having low maintenance regression tests, we can conduct flexible, more frequent test runs. We improve the test coverage by having high test coverage test data and more frequent test runs in automation. So in total, we saved time and resources for our customer. So let me summarize. The quality assurance of enterprise software is complex, extensive, so conducting manual testing alone is not realistic. To cover the quality is not realistic. If you don't introduce automation, you have no chance to cover the quality, to assure the quality of enterprise software. Additionally, if you conduct traditional approach of test automation, this is insufficient, because you have to conduct extensive test automation, and here you need absolutely a generic approach in order to generate the automation, like the example I showed in today's presentation. So thank you so much for your attention, and let's have a look if we have any questions.
Lilia, thank you so much. That was a very compelling presentation and very valuable demo. I'm just going to say here, if people want to refer back to it, because it's so jam-packed with useful information, then we will have a recording. I think it'll probably go into YouTube channels, but we will share information about that if somebody does want to look back. Can we just look at the questions, please, that we have? How does your approach differ from the one described in the ISTQB syllabus for model-based testing?
This is a nice question. And let me add to your question and also the ISTQB syllabus for test automation advanced version 2.0. So the syllabus describes an automated generation of test cases from models. It's called test generation. So the entire test case is generated automatically based on the model. Now, in contrast, the model-based approach I presented, it will be integrated in your test case. So basically what you do before and after calling this innovation or calling this tool is yours, is entirely up to you. The tool is taking over the extensive filling and checking of forms to facilitate and accelerate your automation. Basically, both methods are definitely model-based and undoubtedly they contribute to efficient quality assurance.
Thank you, thank you. Another question, please, if we have one. Your model-based approach requires an A12 framework and QF test. Can your approach be implemented with any application and any test automation tool?
This is a nice question, very interesting. Yes, if we are able to scan the UI of any application and create models from it, for example, by using AI, which is very realistic, then we can realize this model-based approach with any test automation tool. And now let's go one step further. If we would like to generate also valid test data, not only conduct the automation of automation, but also generate test data, then we need to enrich this model with the necessary validation and calculation rules. Generally speaking, models, as I mentioned before, have a structure and are very tangible. So we can extract valuable information from the models and invent tools that bring really a lot of efficiency and the quality assurance of enterprise software.
Lilia, thank you so much. We've reached time. Fantastic. And as I say, we will share how people can access the presentations again, because I know people want to watch that. Just a reminder to everybody, if you would like to go to Lilia's profile on the A4Q Testing Summit website and cast your votes, please do, for Best Presentation, Best Speaker. And please stay tuned for the rest of the sessions in today's A4Q Testing Summit. Lilia, huge thank you. That was great. Thank you.
Thank you so much. Hope you enjoyed enjoy the rest of the A4Q Testing Summit. Wish you a nice time. Thank you so much. Goodbye.
Thank you. Bye.